Good evening, Earth Science students. Tonight we're going to learn about weather station models. Teaching point: to interpret a weather station model. Do now, during the course of this video, please open up your notebook and write the following. 1. Teaching point in a table of contents. 2. Teaching point for your notes. And 3. Notes that are in yellow font. Any vocab, of course, will be given to you. Actually posted on Jupyter to put in your glossary. Okay, weather station model, abbreviated as WSM, communicates specific information about the weather over a specific area in one small diagram. This is found on page 13 of the ESRT. Station model weather information includes 1. Cloud cover, right at the center. In the upper left, temperature. Middle left, visibility. Next to visibility is present weather. Bottom left, dew point. Then we have the shaft, which is the wind direction. We have the wind speed, which is the feathers from the wind shaft. In the upper right, we have barometric pressure. Middle right, we have the barometric trend. And the bottom right, we have precipitation. Okay, number 1, WSM and cloud cover. This will cover percentages, and usually, they could be any percentage, but they usually go by quarters for Earth Science students, like yourselves. So 0%, 25%, 50%, 75%, or 100% cloud cover. So if the circle is not shaded in, it would be 0%, but the more you shade in, right, the more cloud cover you would have. Right, so 0% cloud cover would give you a high pressure with clear skies. 100% cloud cover would give you a lot of humidity. Number 2, you already had this down from our lab, so no need to write this down. Number 2, WSM and temperature, and it's measured in Fahrenheit, only in Fahrenheit. You can make conversions if needed using page 13 of the reference table. And there are no units on the weather station model. 3. WSM and visibility. This is measured in miles, and there are no units on the weather station model. 4. WSM and present weather. There is a table for all the symbols that represent present weather conditions. This table, right, is found on page 13 of the reference table, right next to the weather station model. And there's a whole bunch of symbols for all types of weather conditions that we can use. WSM and dew point. This is also measured in Fahrenheit, like with temperature. No units are on the weather station model. And you can also utilize the dew point values from page 12 of the ESRT with the dew point. And in addition, you can also figure out the relative humidity with the air temperature and the dew point temperatures on the weather station model. So you can really utilize both tables on page 12 of the ESRT from the WSM. 6. All right, you're going to have this down already from the lab. Wind direction is a shaft extending from the circle. The shaft can be at any compass direction. It could be north, south, east, west. It could be northeast, northwest, southeast, southwest. It could be north, northeast. It could be south, southwest. Right? It could be at any direction. Wherever the shaft is located, that means that's where the winds are coming from, right? Not where they're blowing to. 7. All right, this is also something that you already have from your notes in the lab. Wind speed of feathers extending from the wind shaft. Each feather is 10 knots. If wind speeds are calm, you have no feathers. If wind speeds are less than 10 knots, one small feather just below the end of the shaft. So we have, let's see, from 3 to 7 knots, anything below 10, you would always have a small feather from from the end, just near the end of the shaft. Otherwise, everything else is to the end of the shaft, and then what other feathers we need. All right, so for instance, if you're looking for a 40 knot wind speed, you have 4 equal length feathers. If you have 35 knots, you would have 3 equal feathers and then 1 half the size to make it 35. WSM and air pressure. All right, now you already had this from your lab. Measured in millibars, MB. No units are on the weather station model. And we have 2 rules, rule 1 and 2, for the weather station model into the actual air pressure. If the 3-digit number is below 500, you add a 10 in front, and you place your decimal between the last 2 numbers. And then rule number 2, if the 3-digit number is above 500, we add a 9 in front, and place a decimal between the last 2 numbers. Those are our 2 rules. Now, to go from the actual air temperature to the weather station model, we just take the last 3 numbers and drop the decimal, as we did in lab class together. 9. Weather station model and barometric trend. All right, so the barometric trend is over the last 3 hours, and we have at least 2 points here. We have plus and like a positive slope line. That's an increasing value. A minus and a decreasing slope is a decreasing value. And the rule that we have is they give you only 2 numbers usually, so you would just place a decimal between the last 2 numbers. If there were 3 numbers in total, then you place it between the last 2 numbers. Alright, so practice. Barometric trend. Alright, so the station model below shows the weather conditions at Houston, Texas at 9 o'clock in the morning on a particular day in June. We have a whole bunch of stuff, right? We have 74 degrees Fahrenheit. We have 72 degrees Fahrenheit for the dew point. Visibility is 10. Cloud cover is 50%, half of it shaded. Winds are coming from the south, probably from the south-southeast or the southeast at about 15 knots. The pressure would be 1,000.2 millibars. The number is below 500. We have a negative trend. So it's been decreasing 3.1 millibars over the past 3 hours. And the amount of precipitation we had is 0.5. Alright, so what was the barometric trend or barometric pressure at Houston 3 hours earlier on that day? So we need to utilize 2 numbers, pressure and trend. So our air pressure is 1,000.2 millibars, right? It's below 500, add a 10 in front, place a decimal point between the last 2 numbers. Next, our trend. Our trend is decreasing, and we place a decimal point between the last 2 numbers. So 31 is equal to 3.1 millibars. Now we have to do some math. So if it's been decreasing over the past 3 hours, that means that 3 hours ago, in the past, we had a higher pressure. So we take 1,000.2 millibars. In order for it to be a higher pressure, we have to add the trend. All right, so it's been decreasing over the past 3 hours. So once again, 3 hours ago, it was a higher pressure. We get an answer of 1,003.3 millibars would be choice number 3 on this Regents question. All right, last point, WSM and precipitation. Measured in inches, IN, over the past 6 hours, and no units are on the weather station model. Okay, That will conclude the weather station model. When you come into class tomorrow, be ready for a quick assessment and an activity pertaining to weather station models and Regents questions. Please make note that you need to know that information on page 13. You need to know the present weather conditions on page 13. You may need to consult for conversions on page 13. And you may need to refer back to page 12 for the relative humidity and the dew point temperatures. So you can utilize both pages for the weather station models. Have a good night, ladies and gents. See you tomorrow.